And it's a solving equation. One half sine 2x minus cos 2 squared x. So according to the note that we just wrote, would this be a multi-revolution question or one where you'd use an identity? An identity, because there's that extra cos squared in this equation. So the first thing I'm going to do is I'm going to change and the 1/2 times the 2 is going to change that just to sine x cos x minus cos squared equals 0. Now when you're working at these questions, and we wrote down those strategies before, at every step you should go through those strategies and see what are all the things I could do. So in this case, I say to myself, could I change things to sine? And I see a cos squared, and I could change that to 1 minus sine squared. Could I factor? I see a cos in each expression, I could factor. There's no more double angle identities, so I don't have to worry about those. So I sort of see changing the cos squared to 1 minus sine squared as one option, and factoring as the other option. Now, if I changed to 1 minus sine squared, I would still have sine and cos in the expression, so I'm not sure if that would help me very much. And if I did change that, I would have an additional 1, which probably means I can't factor. So I'm going to start by just trying to factor and see what happens. So when I factor here, I'm going to get cos x. I'm left with a sine x minus cos x equal to 0. This is nice because the cos is all by itself. This is still not very nice, but there is a way to solve this one as well. So we have cos x equals 0. That's good. Over here, you have sine x equals to cos x. There is a way to change this to just one trig function. Sine x equal to cos x. And it only works when you have just a sine and just a cos. If I rearrange this by dividing by cos, this side will become 1, and this is tan. The other thing some people do sometimes when they get sine x equals to cos x, they think of their unit circle and say, is the x coordinate ever the same as the y coordinate? And that happens when you have root 2 over 2, root 2 over 2. So you could just think about your pi plate and say, yes, I know that sine x is equal to cos x at pi over 4 in quadrant 1, because they're both root 2 over 2, and also in quadrant 3, where they're both negative root 2 over 2. So you might be able to go directly from here and say that x is pi over 4 and 5 pi over 4. If you change it to tan, it's easier, because you're like, when is tan 1? That's part of my pi over 4 family. And it's positive in quadrant 1 and quadrant 4. And for cos equaling 0, that happens at pi over 2 and 3 pi over 2. So this is a little bit tricky with this sine x minus cos x in there, but there's two ways, either by observation and thinking about your unit circle how to do it, or you could change it to tan. Questions you can do with this one are 12, 13, 14, and 15. And then on the back of your identity sheet where you had a whole bunch of proving ones, there's solving questions on the back. And I'm going to write down on that worksheet, you can circle 8, 9, 11, 12, 14, 15, 21, 27, 29, and 31. And make sure you bring that sheet tomorrow because we're going to be taking some class time to work on it during class. So the identity sheet with all the proving ones, on the one side was prove, 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 and on the back side is solve, 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 solve.